A6, right? So this now is going through and asking to write out the balanced redox reactions in an acidic environment. Right? And so to do this, right, the first thing you always want to do is you want to write out what the two half reactions are. So looking at it, right, so we have one half reaction in this case, which is the S. Come on, did this really die on me? My pen just died. It's gonna be a pain to do without the pen. I might have to just end the stream for now. I'm just gonna end the stream for now. I'll be back again at 1:30. I'll work on the kinetics packet for that one. And if there's more things, right, I'll just work then on more of this packet as well. Go through an example of this, but I have videos just going through how to use this approach. If whoever's watching this, right, if they're one of the reasons why you voted on this was because you're like, oh, I think there's a mistake, right? Like, let me know on Piazza so that way I can double check. But they should all be correct in these cases, right? But again, if you haven't watched Dr. Chen's videos on it and you haven't watched the videos that I've posted on it, right? I recommend doing those, right? And then hopefully that'll clarify the approach, right? Because all the approaches for these types of things, I'll just talk my way through it right now for a brief second. Is that because hopefully maybe the pen will come back. Is that you cut it, like if you have a full reaction like that, you break them down into the two half reactions, right? So for part A, right, you have the reaction where you're going from the S2O3 2 minus, right, to form the SO4 2 minus. And then the other reaction is you're going from Cl2 to form the Cl minus in those cases. And so the first thing that you do in those cases is you make sure that you balance all non-hydrogen and non-oxygen atoms in those scenarios. And so, right, for the S2O3 part to SO4 minus, right, what I would do is then put a 2 in front of the SO4 2 minus, right, because you're going to have to form two of those if you're going to be doing a reaction with two with just one of the S2O3 because it has two sulfurs, the other one only has one. First, you do all that balancing. The next thing you do is that you balance out the oxygens by adding in waters, right? And so, you would add however many waters you needed to one of the, either the product or the reactant side to balance out the number of oxygens between, the products and the reactants. Once you've done that, you then add in however many H pluses you need to whichever side needs them to balance out the number of hydrogens, right? And so then you do that. You should then get all of those. And the last thing you need to do is just simply you add in electrons to make sure that the charges are balanced on both sides in those scenarios. So you do that for one half reaction. You do that for the second half reaction. Then you combine those two reactions together and cancel things out, right? And so everything needs to be balanced, right, in terms of the number of electrons. So that should, again, be the guiding principle in figuring that out. And then hopefully, and once you do all of that, right, and everything has been canceled and everything is completely balanced, right, that'll be then your full, redox reaction in an acidic environment. Let me see if the pen works now. Yeah, pen works again. All right, so I just talked my way through it. I'll show my way through it now. So A6, right? So if we look at this right here, right, the two half reactions we have is S2O3 2 minus yields SO4 2 minus, and then the other one we have is Cl2 yields Cl minus, right? Those are the two half reactions that we have going on. So the first thing that we want to do is we want to make sure that we balance out the non-hydrogen and non-oxygen atoms. So in the left case, right, that's going to be the sulfurs, right? So we have two sulfurs on the left. We only have one on the right. So all I got to do is throw a 2 in front of the sulfate. That balances that part out. The next thing we want to do is we want to make sure that we balance out the oxygens by adding in water molecules as necessary. So if we're looking at the left, right, we have 3 oxygen atoms. If we're looking at the right, we have 8. And so there's a difference of 5 in those cases. So now we're simply going to add 5 H2O in this case to this side. So we have 5 H2O plus S2O3 2 minus yields 2. I'm going to give myself some more space so that way I can also add in the H pluses if needed. Well, it'll be on the right side. So that's going to be S2O3, right? And so that's 2 SO4 2 minus. Should have given myself more space overall. Right, so we have 5 oxygens plus 3 is 8. 2 times 4 is 8, right? So the oxygens are all balanced. Now we have to balance out the hydrogens by adding in H plus. And so, right, we have 10 hydrogens on the left. So that means we have to add then 10 H plus on the right to balance it out. Right, so now we have the hydrogens balanced, we have the oxygens balanced, we have the sulfur atoms balanced in this case. So now we guys have to make sure that we're balancing out the charges. So if we're looking at the left, we have a charge of 2 minus. If we look at the right, we have 2 minuses from the sulfates, but we have 10 H pluses. And so that gives us a total charge of, what is that, 4 minus plus 10, so that's 6 plus in that case. So we have 6 plus on the right, we have 2 minus on the left. And so we want to balance them out by adding in electrons. So we're going to add electrons to the right side, and we're going to add in 8 electrons in this specific case. 8 plus 8 electrons in this scenario, right? Because that now balances out the charge, so that on both sides you have a charge of 2 minus overall. Right, so that half reaction is all balanced. We balance out the other one. What we have is Cl2 yields Cl minus. So if we balance this out, right, what we have is 2 Cl minus in those cases, right, is going to form. The next thing, right, we would want to do is balance out the number of oxygens, right? There's no oxygens on either side, so we don't have to worry about that. Next thing we want to balance out is the number of hydrogen atoms. There aren't any hydrogen atoms, so we don't have to worry about that either. And the last thing we have to balance out, right, are the number of electrons, right, the overall charge. And so if we're looking at it on the reactant side, there's a charge overall of 0. On the product side, right, we have a charge of 2 minus overall. So that means then that we have to then add 2 electrons to the product side, or sorry, to the reactant side, right, to balance everything out, because now 2 electrons plus. In that case, right, so that everything's balanced out, right? So now that half reaction is balanced out. So now the final thing that we have to do is we're going to have to combine the 2 of them and make sure that we're balancing out the number of electrons. And so for the chloride reaction, right, we're only pumping in 2 electrons on the reactant side, whereas for the sulfite or whatever, S2O3, I can't remember off the top of my head what it's called anymore. Right, that reaction requires 8 electrons, and so that means then that this has to get multiplied by 4, so that way the electrons balance out. So what we end up with then is 8 electrons plus 4 Cl2 yields 8 Cl minus, right? So then now when we combine the 2 reactions together, right, what we have is that the electrons cancel, right? And then nothing else cancels. But now the electrons cancel, right? That's the big thing that we need. And so now the overall reaction is 5H2O plus S2O3 2 minus plus 4Cl2 yields 2SO4 2 minus plus 10H plus 8 Cl minus. In that case, right, so the Cl's balance, right, 4 Cl's, 8 Cl, right, 4 Cl2s, 8 Cl's, right, so that's balanced, right, the number of sulfurs are balanced, the total number of oxygens are balanced, right, the total number of hydrogens are balanced, and the most important thing, right, the charge is balanced, because on the left side, right, we have a 2 minus, on the right side, we have 4 minus from this part right here, we have, 10 plus from this right here, but then we also have 8 minus from that right there, so all that adding up together gives us 2 minus. And so everything is balanced. And so then that right there is the balanced equation for that part right there. right? So that's the most straightforward way to approach this part in these scenarios. So same approach for all the others. But again, as I'd mentioned, you know, if the reason that you had voted on this was because you think I had made a mistake, throw it into Piazza so that way I know which one to specifically look at. And then I'll try to work my way through that one. But you know, it's basically the same approach for all of them in these cases. So